Good afternoon. My name is Lauren OMalley, and today I will be presenting my signature assignment work for DA5030 during the spring semester at Northeastern University. At the business level, my project goal was to examine student drinking habits and see what correlations they may have with their school lives and their home lives. So our problem question here is, what are the heaviest influences on secondary school student drinking habits in Portugal? My data is available via both Kaggle and data.world. It consisted to start of 2 CSV files, which I combined into one. The 2 files had 382 of the same students, so my resulting data set included these students particularly. The students were sampled from math and Portuguese courses from 2 different secondary schools in Portugal. Information such as their age, their gender, their home and family lives, and so on were taken. The focus was on their self-rated alcohol consumption level for both the weekday and weekends. So I merged the 2 CSV files based on the columns of the 382 students I was looking for answered the same for. This information was found on Kaggle. I did not have to do that by myself. But both the math and Portuguese classes, after combining, there were some discrepancies between the data. So despite having school, sex, age, address, etc. the same, many columns students would answer yes for one day and no a second day. So for the numeric data, that was pretty easy to handle. So for things like the number of absences or the amount of free time they have, I just averaged the answers from the Portuguese and the math columns. And for binary columns, I decided if they answered yes at all, that they meant yes in general. And then a little different for feature variables with bigger categories, I decided that if they answered, for instance, their mother was their guardian one day, their father somehow was their guardian the next day, that I would put them in the other category. And this is what the resulting data frame looked like. So as you can see, it's all the same information from the original 2 data frames. However, now there's just some combined information, but it's all from the 382 students that were a part of both courses. I did derive a few more features. Later, I changed the grade columns from numeric to a simple binary pass-fail column. I also, for K&N analysis specifically, I classified students as either heavy, light, or medium drinkers. So here we can see that in the DALC and WALC columns, they were asked to answer with a scale of 1 to 5, 1 meaning very low level of drinking and 5 meaning very high. I thus decided if students said they drank at a level of either 3 or above on weekdays, that was a relatively heavy amount. Medium I decided was an average weekend value of 3, and then a light was a low answer on both weekdays and weekends. So we can see that here I noted the classification method I used, and I just simply used a for loop and then if statements. And remember that these were factor variables, which is why it's equals and quotation marks and not just equals 3. So now onto data exploration. I had many factor features, so I did not need to do too much outlier detection, although I did some. In terms of numeric variables, there were some outliers. So as seen here, there was about 25 in terms of absences, but I decided to keep all the data regardless, just due to the fact that there's only 382 students in the data set, and I didn't really think that an outlier of 14 absences was going to have that big of an effect on the data. So I also plotted the DALC and WALC distributions. So here we can see this is weekday alcohol consumption distribution. So 150 is the highest amount for a level 1, whereas 5, it's about 25 students. Here we can see many more students answered 1, which is interesting. They're answering a lower amount on weekends than weekdays. But we can see that they kind of follow the same type of pattern between the 2, regardless of having different amounts. So besides that, for looking at the data, I found that there was no correlations between the dependent variables, or there was really no scare of collinearity, and also there was no missing data in my data set. For comparison purposes, however, I did randomly select 5% of my data to become missing. So I made 5%, as you can see here, randomly selected data values to be NAs, and then I later imputed them. So I imputed numerical NAs by replacing them with the column average, and then categorical column NAs, I did the mode. So for my 3 models, I chose to do KNN classification, multiple linear regression, and k-means clustering. So my goal with KNN was to classify each student as a heavy, medium, or light drinker, which we discussed earlier. And I had to start by normalizing my numeric data and dummy coding for my feature variables. I started with a k-value equal to the square root of the number of rows of total data, and I ran my model and I evaluated with cross tables, and I found that my predictions were correct 81% of the time, which is pretty good, but I still tried raising and lowering the k-values and just messing around with that, and I saw that there was really not that much change. It kept 81%, so I decided maybe we'll try normalizing differently. So as you can see here, I used z-score standardization the second time around, and yet again I found that there was no change, that there was 81% accuracy, and interestingly enough, only predictions for a medium drinker classification. Next, I decided I was going to determine which attributes were most important in determining how much a student will drink on weekdays specifically. So I ran multiple linear regression, and to start, I found that absences, going out amount, and a reason to attend specific school and travel time to be the most statistically significant. But with this, I saw that the model's R-squared was only 0.15, meaning it only explained 15% of the variation in weekday drinking. The 95% confidence interval for an example student with unknown values, I found that it was naturally pretty large, but in the way I classified student drinking habits as well, a range from 0 to almost 4 is basically the entire range, so you're really not missing anything there. It could have been a lot more specific. So then finally, I decided to run clustering. And I used k-means clustering, and I wanted to see what influences I thought would be of the most important. So I chose age and the amount of time they spent going out, because in my mind that might affect how much somebody drinks. So I noticed interestingly that students with similar ages and going out habits did exhibit nearly the same drinking habits, no matter if it was a weekday or a weekend. So we can see here that the two graphs really aren't that different in the grand scheme of things, and the way they're clustered is very, very similar. So clustering worked pretty well in visualizing the similarities and the features, and I thought it was kind of pretty influential. And the k-value, though, didn't do too much. We had the same range of values covered, and 5 and 3 as a difference didn't really play that big of a role in my mind. So I found that k, with sticking with 3, was okay. So the effect of missing data was kind of interesting in my mind, but it really wasn't that significant. In the project, I ran 3 models on normal data. I tuned them and I repeated until I found the highest accuracy I could, which unfortunately wasn't always super accurate. I used these tuned models on my fake missing data sets as well. So for K and N, I found that there was very little difference in model accuracy. The normal data model ran an 81% accuracy, while the imputed set ran 84%, which is interesting that it's a little bit higher, but only 3% isn't that special. In the case of multiple linear regression, the comparison is important, as the 2 models found very different statistically significant dependent variables, which with real-world data could definitely change and influence how someone analyzes information, if the information's even correct, or how people go forward with their decisions. And finally, I found that there was very little difference in the clustering graphs. So this is for my normal data set, and then down below we have the clusters for the missing data set. So there's really no difference between the 2 at all, naturally. So a comparison between the 3 models, KNN, linear regression, and clustering, they're all pretty different, and they provide different insights, which is why I believed it'd be beneficial to run each. I find in general that KNN and linear regression, they're the most useful. The clustering is just nice because you get a nice little visual. But so I ran a stacked ensemble model on KNN and linear regression. And here are my findings using the carrot package. I found overall that linear regression provided better results, despite the fact that I found KNN to run better in my model. But here we see that they're both kind of low anyways, both falling below 50% for almost all of the values. So in general, I found that the data set was okay. There were over 30 columns, which means that there were many potential influencers on the chosen dependent variable. Looking back at the original data, I see it's clear that there are really only about 2 or 3 features that I can see playing a huge role in this type of thing, in their drinking habits. It asks things such as the romantic relationship, the age, which, could have an effect, but not that influential of an effect, so I'm not too sure what they were aiming to find with this data, but it makes me more comfortable with the results of my models. So I wasn't getting the best results for, say, linear regression. I was getting kind of weird answers to those, and it makes more sense to me looking back at the data. Also, at first I thought that quantity over quality for columns, but now I see that you could have maybe 5 feature variables, and if they're important and they play a big role in your data, then that's fine. I had over 30 columns to work with, and it got stressful, especially since they were all factor variables mostly. And just, it's not size that matters. Although I do believe that the number of rows, the number of people you get to give you data, in this instance, number of students, plays a key role. So if I were to redo this project, I probably would just use the larger of the 2 data sets, either Portuguese or math. I wouldn't combine the 2, just so I could have more data, more chances to see students and how they interact. And that is all for my project. Thank you very much, and I hope you enjoyed.